So welcome back everyone to this Academy of Mathematics. You're welcome to today's lesson. My name is Courage and this is Courage Mathematics Academy. Once again, you're welcome. And if this is your first time of joining us, hit on the subscribe button right now and turn on notifications so that you get updated and notified whenever I upload wonderful content. For today, we are going to consider area of sector, the formula and examples to buttress the principles. Let's get started with today's class. Now, this is a circle with center O, for example. And if I draw a line from this center to any point on the circumference, that line is called a radius. A radius. In the same vein, if I draw another line from this same point to another point on the circumference, it is called a what? A radius. Now, this point, from this point to this point, I have this curve, and it is called an arc. That is, an arc is a part of the circumference of a circle. So when you share the circumference of a circle into two or more parts, you have arcs. So this is obviously an arc, and this arc subtend an angle theta at the center of the word of the circle. This is a sector. Yeah, this is a sector. So what is a sector now? A sector is a part of the circle, or a sector is a plane figure that is formed by an arc and two radii. This is a sector. We just formed a sector bounded by two radii and one arc. So the region of a circle, or simply say a sector, is a plane shape that is formed by two radii and an arc. That is what a sector is. And the area of the sector is equal to the angle subtended at center, which is theta, over the entire angle of a circle is 360 degrees, over 360, times the area of a circle. The area of the circle is what? Pi r squared. So the area of a sector is theta over 360 times pi r squared. Good. Now in this circle, I have two sectors. One is the minor sector and one is the major sector. Now, there is no big difference between these two sectors. The difference between this major sector and this minor sector is the angle that is formed at the center. The angle of this major sector is usually greater, that's why it's called major, than the one of the minor sector. So when you are asked to find the area of the sector, whether it is major or minor, always take note of the angle that is subtended at the center. It's very, very important. So with this, we are going to solve some questions to buttress our points. And now we have our questions on the board to solve, the two questions that we have on the board. And the first question says, a sector of a circle of radius 21 centimeter subtends an angle of 70 degrees at the center. Calculate the area of the sector. Calculate the area of the sector. So now drawing the sector, I have something like this. The radius is 21 centimeter. 21 centimeter. And the angle subtended at the center is 70 degrees. So here is what? 70 degrees. And we are asked to find the area of this what? Sector. So what we'll do is, the area of sector is still there. The area is equal to what? Theta over 360 times pi radius squared. This is equal to what? Theta is 70 degrees. 70 over 360 times pi is always 22 over 7. 22 over 7. And the radius is 21 centimeter. So this is times 21 squared centimeter squared. So what do we do? Going by this, 70 times 22 times 21 times 21 is equal to 679,140 centimeters squared. All over 360 times 7 is 2520. So this divided by 2520 gives me 269.5 centimeters squared. So this is actually the area of this sector. So having solved the first question, let's see what the second question says. It says the circle of diameter 20 cm subtends an angle of 90 degrees at the center. Calculate the area of the major sector. We have to find the area of the major sector now. What is the difference between the major sector and the minor sector? Like I told you earlier, the difference is in the angle subtended at the center. That's the difference. Now let's see. This is the circle, for example, and the radius, okay, it is a diameter, has diameter of 20 cm. Obviously, we are not going to do diameter, but I know that diameter is equal to 2 radius. So it means that 1 radius is equal to diameter over what? 2. So I'll make use of that. So the diameter is 20 cm. Then my radius will be half of 20 cm. That's 10. So my radius is 10 centimeters. Now, they said that the sector subtends an angle of 90 degrees at the center. So 90 degrees at the center will be here, 90 degrees. Now, obviously, I know that this sector here is not the major sector because the angle at center, which is 90 degrees, is less than the angle at the center of this major sector. That is, the angle formed by this minor sector is less than the angle formed by this major sector. Now, how do we get the angle formed by this major sector? It's simple. Subtract 90 from 360. Everything here is angles at a point. Everything here, that's 360 degrees. And part of it is already 90. So it means that the other part will be 360 minus 90. And that's what? 270 degrees. So you can see that the angle formed by this other sector is 270 degrees. And it is greater than the one formed by this other sector. It means that this one is the major sector. So we will now look for the area of this major sector. The formula still remains the same. So the area of major sector is still theta over 360 times pi radius squared. Now what's theta? We will not use 90 but 270 degrees. That's 270 degrees over 360 times pi is always 22 over 7. 22 over 7 times the radius is still 10. That's 10 squared centimeter squared. And what will this give us? 270 times 22 times 10 squared. 594,000 centimeters squared over 360 times 7 is 2520. So this divided by 2520 is what? 235.7 centimeter squared. So this is the area of the major sector. Take note of the principles that I have given you so that you use to solve other questions on your own. I'll see you some other time in my next video. Subscribe, like, and tell your friends about this channel.